In topic 2.5, we're going to be using scatterplots and prediction equations. Scatterplot is just when you're modeling data. So you'll take your ordered pairs from your data set and you'll model them on a graph. It will look scattered because in the real world, data is not always perfect. You can then use your scatterplot to determine if there's a relationship among your data. Usually we draw a line of fit or a line that goes through the center of most of the lines and use that to make predictions. So here we have our different types of correlations. Correlation just means relationship. When you're graphing two things from the real world that cause each other to increase, you have a positive correlation. So if you're looking at the graph on the left here, this could be like the number of hours you study for a test and your grade on the test. Because typically, not everyone will earn a higher grade for studying, but the trend should go up. If you have a strong correlation, that just means that when you're looking at your data, your points are very close to that trend line or line of fit. If you look at the second set of data here, it's a negative correlation. That means that something is causing something else to decrease. So it could be, for example, like the temperature outside and the number of people wearing sweaters. Because typically the hotter it is outside, the bit higher that temperature, less people will be wearing sweaters. But that'll be a little scattered because some people wear a sweater either way. Some might not wear a sweater when it's cold. So that slope there, it's negative because it's typically going to decrease. The data here is weak because you can see the points are further away from that trend line. And when your two data don't really affect each other, then you'll have no correlation. So your data will look all scattered. You can't tell if it's going up or down. This would be something like the number of siblings someone has and maybe their shoe size, because typically one will not affect the other. Here we're going to actually practice drawing our scatter plots and using them to make predictions. So here we have a table that shows the experience for 8 technicians at Lewis Tech-O-Matic and their hourly rate of pay. So let's go ahead and start with A, where it asks us to draw a scatter plot to show how years of experience are related to hourly pay. So I'm going to be graphing these points starting with 917. Here it doesn't have to be perfect, we're just estimating where these points go. Next we have 410, 310, 17, 1019, 612, 1220, and 815. So part A asks us to draw our scatter plot. Part A also asks us to draw a line of fit and describe the correlation. So I'm going to draw a line that goes through the center of most of these points. And then I can see this one's going up, so it's positive, and my points are close to that line of fit, so it's a strong correlation. So this has a strong positive correlation. Question B is asking me to use 2 ordered pairs to write a prediction equation. So when you're choosing the ordered pairs, you want to choose ordered pairs that are close to or on that line of fit. There's no right or wrong answer, but I want to choose ones that are touching or close to my line of fit. So I could use the one here. That one's at 310. And I could also use the one right here, which is at 917. Again, those aren't necessarily the only points I could choose. I just want to choose points that are close to that trend line. So I'm using my points at 917 and 310. And I'm going to use this to write an equation. Well, you should know from our previous topics, when you're writing your equation, you want to find your slope. So we're going to have to use the slope formula to get our slope here. So I'm going to plug in for y2 minus y1, 10 minus 17. For x2 minus x1, 3 minus 9. This comes out to negative 7 over negative 6. Remember, two negatives become positive, so it's positive 7 over 6. Now I'm going to use point-slope form because I want to write an equation. So y minus y1 equals m times x minus x1. Our slope was 7, 6, x minus 9. 7, 6 times 9. 7 times 9 is 63. And then you would do 63 over 6. I'm going to actually change these to decimals just because I'm going to be using this to predict, so the fractions might get in my way. So I have y minus 17 equals 7 over 6 comes out to about 1.17. And 63 divided by 6 comes out to about 10.5. So now I can add 17 to both sides. If I do negative 10.5 plus 17, that comes out to positive 6.5. So now I have a prediction equation I can use. Again, since we're dealing with data, if you get fractions, just change them to decimals because we are going to plug in. And when you plug in, we want to get numbers that are more meaningful to us. So I have my prediction equation. Now I'm going to use this equation to predict the hourly rate of pay for 15 years of experience. So my number here is 15 years. And if you remember, the years was our X here, and the rate of pay was our Y. So I'm going to plug 15 in for X. And then I can start simplifying. So I'll do 1.17 times 15. That comes out to 17.55. And then I can add 6.5. That comes out to 24.05. I want to make sure my answer makes sense. So if I look at the hourly rate of pay, these were all whole numbers. So to be consistent, I'm going to round it to a whole number. And then my units are dollars. So this would come out to about $24. And that's the hourly rate of pay. For 15 years. So usually when you have word problems, you want your answers to make sense. You can answer in a sentence. Just make sure to use units. So to summarize, what we did here is we drew our scatter plot by plotting our points. Then we drew our line of fit that went through most of the points. Since our points were close to the line, it was strong. Since it was going up, it was positive. When you're writing a prediction equation, you can choose 2 points. It's best to choose points that are close to your trend line. You could have used any 2 points from the data, but try to choose 2 points again that are close to or touching that trend line to have a more accurate answer. And then we use this, once we had our 2 points, we found the slope, and then use point-slope form to write that equation, and then we could plug in to make our prediction.